Now, backwards compatibility was handled masterfully by AMD. They treated it as a key need throughout the design process. As our solution to adding new features without blindsiding developers, we made sure that if there were new significant features, it would be optional to use them. The GPU supports ray tracing, but you don't have to use ray tracing to make your game. The GPU supports primitive shaders, but you can release your first game on PlayStation 5 without making any use of them. And the PlayStation 5 GPU is backwards compatible with PlayStation 4. What does that mean? One way you can achieve backwards compatibility is to put the previous console's chipset in the new console, like we did with some PlayStation 3s, but that's of course extremely expensive. A better way is to incorporate any differences in the previous console's logic into the new console's custom chips, meaning that even as the technology evolves, the logic and feature set that PlayStation 4 and PlayStation 4 Pro titles rely on is still available in backwards compatibility modes. One advantage of this strategy is that once backwards compatibility is in the console, it's in. It's not as if a cost down will remove backwards compatibility like it did on PlayStation 3. Achieving this unification of functionality took years of efforts by AMD, as any roadmap advancement creates a potential divergence in logic. Running PS4 and PS4 titles at boosted frequencies has also added complexity. The boost is truly massive this time around, and some game code just can't handle it. Testing has to be done on a title-by-title basis. Results are excellent, though. We recently took a look at the top 100 PlayStation 4 titles as ranked by playtime, and we're expecting almost all of them to be playable at launch on PlayStation 5.